Let's go over a couple of questions for this week's discussion quiz. In question 1, we're asked to find the critical numbers for the function f of x, which is equal to x times e to the 1 minus x squared. By definition, a critical number is wherever the derivative of a function is either equal to 0 or does not exist. So let's start by computing f prime of x, the derivative of the function. I see we have a product of two functions. It's x being multiplied by e to the 1 minus x squared. Therefore, we have to use the product rule. But also, we have to use the chain rule because we have a composition of two functions. So the product rule says that you take the derivative of the first. So it's going to be 1, and then we just copy down e to the 1 minus x squared, its derivative. To this, we leave the first function alone, but now multiply by the derivative of just e to the 1 minus x squared. The derivative of e to anything is e to that thing, but by the chain rule, you have to multiply by the derivative of what's composed inside the function. The 1 goes to 0, and we get a minus 2x. Now, looking at this equation for the derivative, it always exists. So I have to check to see where it does not exist. Like, that's not going to happen. We only need to check to see where this thing is equal to 0. I'm going to try to simplify it a little bit. I don't need this 1. Maybe I'll call this minus 2x squared. So that is, for this first piece, I'm just going to write this. That's e to the 1 minus x squared. I'll bring the negative in front. I'll also bring the constant of 2 to the front. We have an x times an x, that is x squared. And then we have e to the 1 minus x squared, and this is equal to 0. The approach to solving this one is to factor, and I'm seeing that I can factor out this and this from both terms. In doing so, if you factor out e to the 1 minus x squared, in parentheses, you have to have something left over here. That will just be 1. And then you'll have minus 2x squared. You can check by multiplying this back in. It'll take you to the previous line. Now, where does this equal 0? That's wherever each individual factor is 0. And the good news is, for this factor over here, e to the 1 minus x squared, it actually never equals 0. An exponential function like this never is 0, so this will provide no solutions. That means we only need to check where 1 minus 2x squared is 0. I'm going to add the 2x squared to the other side of the equation. I'm going to divide both sides by 2. And if you take the square root of both sides, you get a plus minus is equal to x. That is, plus minus root a half is equal to x. Those are two numbers that make the derivative of this function equal to 0, and therefore we have two critical numbers, plus or minus the square root of 1/2. And that is the answer to this question. In question 2, we're given the graph of the derivative of some function f. So not the function itself, but what its derivative looks like. And we're asked to determine the x values of any local minimums or local maximums, again on the original function f. Well, local mins and maxes can only occur at critical numbers. Those are places where the derivative either does not exist or is equal to 0. And by looking at the graph of the derivative, there's only 3 places where this happens. Those places are here, the derivative is equal to 0. It equals 0 here and here. It exists everywhere else, so we only have to consider x is equal to 1, x is equal to 2, and x is equal to 4. These could be mins, maxes, or actually neither. And to do this, to figure it out, we're going to use the first derivative test. All this means is around each critical number, you just have to check to see if your derivative goes from positive to negative, negative to positive, or neither. It doesn't change. It stays positive or stays negative. Let's start with the one at x is equal to 1. The derivative goes from a negative value to a positive value. So if you go from negative to positive on the derivative, that means the original function is decreasing and then it is increasing. This must be a local min. And this is by the first derivative test. The derivative goes from negative to positive. The original function is decreasing, then increasing. That is a minimum value. What about x is equal to 2? The derivative goes from positive to positive. That means the original function is increasing and then increasing, and so this is neither. This is neither a local min nor a local max. And then lastly, at 4, the derivative goes from a positive number to a negative number. So positive to negative. When that happens on the derivative, that means the original function is increasing, then decreasing. Therefore, there must be a local max. So again, we use the first derivative test. This is what the derivative was doing just by looking at the graph of the derivative. And from that, we can infer what is happening on the original function itself.